Okay, welcome back to Calculus 2. We are going to integrate dx over 4 minus x squared raised to the 3 halves power. Since we have a square root of a square here, right here, 3 halves power tells me it's a square root, and there's a square root inside. That should be telling me, like, hey, this is some kind of a triangle that we can go ahead and deal with. So I'm going to go ahead and draw ourselves a little triangle here. Use my theta. And then since it's a 4 minus x, we're going to say that I want 2 to be in my hypotenuse, and then x is going to be in one of my sides, and then 4 minus x squared by Pythagorean theorem is going to give me the rest. All right, so that's what we've got here. Let me rearrange this because we're going to say that sine of theta is equal to opposite over hypotenuse, or x equals 2 sine theta. We have to take our differential, so we have dx equals 2 cosine theta d theta. All right. Now, the next thing we're going to be dealing with here is we're going to say that I think that secant of theta is equal to 2 over the square root of 4 minus x squared. I don't really want that because there's three of these. There's the power of three of these. So I'm going to go ahead and cube both sides of this equation, or this relationship. So we're going to have secant cubed theta is equal to 8 over 4 minus x squared raised to the 3 halves power. Okay, so that might be a little bit easier for us to kind of figure out here. So what I'm going to do is I'm going to say, okay, let's go ahead and put an 8 here and a 1 over 8 there. So now this 8 over 4 minus x squared raised to the 4 halves, that is right there. That's my secant cubed. So we're going to have 1 over 8 integral. We have a secant cubed theta. Okay, what is my dx? Well, my dx is going to be 2 cosine theta d theta. So we have our 2 cosine theta d theta. And then if you remember some of the trig, you're going to say, wait a minute, secants and cosines, they get along pretty well. One cancels the other. So we're going to have 2/8 that are known as a fourth. So we have 1/4 integral of, it looks like secant squared theta d theta. Oh, that's not too bad. That's one of those integration facts we're supposed to know. So that's just going to be 1/4 tangent of theta plus c. We're not going to leave it like that because what were we given the original problem in? We were given the original problem in x's. So I'm going to go back to my triangle. I'm going to say, what the heck is tangent of theta? Well, that's going to be x over the square root of 4 minus x squared. So we have 1 over 4 times, and then we could look back up at our triangle. So we have x over the square root of 4 minus x squared and plus c. And I think that's what we're actually going to be dealing with. Okay, we'll go back to our original x's. So that's how you do a problem like that. These can be a little bit tricky. These can be a little bit tough. Try to keep substitutions correct. Make sure you're taking your differential and just kind of work it through and just replace each piece of the original integral with a piece with the theta in it, and it will work out. Okay. Thank you very much for watching the video. I'll see you in the next one. And until then, take care.